Our goal here is to explain and show best practices for collaborative development, but usually they can be applied to development that is done by a single person as well. And we want to motivate the use of Git and development platforms. I mean, you could replace Git by others, but it's a de facto standard. And also, we want to motivate you to make your own codes open source and to contribute to other open source codes, because the workflow that we're going to present and the platforms, that is actually your entry gate into the open source community, and where you can make yourself useful to the overall community, as well as get input from others. And we want to highlight everyday problems, so not go into details which you will, well, maybe come up every other month, but rather than the everyday problems that you're going to face when you're developing in any code. So it's more practical or how-to oriented. And of course, please feel free to ask questions at any time. So interrupt us or write into the chat. We are happy to take your questions in between. So first of all, I just want to do a quick survey. Move your mouse to where you would place yourself in this graph. So if you're using Git, then move further down this tree. And if you're using a development platform, for example, GitHub, move yourself into that specific box. If you're not using any development platform whatsoever, then go to another one, and the no box, and so on. Well, I think you get the hang of it. Okay, that's already useful to know. So there are even there are actually quite a lot of people using locally hosted platforms. So I suppose it's GitLab what you're using?
I cannot do two, or?
No, you cannot do two. Choose whichever you prefer.
I oscillate.
Okay. Okay, yeah, thanks. So that was actually quite interesting. I'll have a couple more of these surveys in between. So now you already know the deal, how it works. Oh, nice. Okay, just a quick thing in between, in the beginning, before we actually get started on the on how to use the development platforms and how to put it into practice. If you want to learn something more about Git, in addition to last week's talk, we came across this game, and it's called Oh My Git, and you can learn in a playful way how Git works and how to apply it. And it actually comes with a fully featured shell, and you can try the commands, but there's also some graphical interface that shows you what is going on behind the scenes when you're using Git. And actually, you can also, intermediate users can learn something from this little game. And I would highly recommend checking it out, because it's even just interesting how they implemented showing a software and showing off how these concepts work. So now our general overview. First of all, we're going to talk about collaboration platforms, what they are, what you can expect from them. Then we're going to move to a specific one, GitHub, to say. We're going to talk about how to set up new projects, how to work together, how continuous integration works, and then eventually get to tags and releases and some other features. This specific workflow is not bound to GitHub. So you can pretty much apply these workflows to other platforms as well. We chose GitHub because it's the standard for open source software. Now, why would you use a Git collaboration platform? Because you could always just run the Git, your Git repository in your code repo. You can rsync it to some other server. There is, well, in feature-wise, you don't really need it. But it makes many things very convenient. So first of all, they host your repository and metadata. So well, while you shouldn't use it as a backup service, it makes it sharing very easy. So you can give other people just a link to a repository or your project, and they will easily be able to get an inside view without having to check it out at first, but also guides them through the process of copying your repository. So it is a web front end. It's easy access even for people that have not used Git before, because usually these platforms allow you to download the code and view the code on the spot as well without having to use Git. They come with user management, so you can add your collaborators, give them permissions. They come with project management tools such as issue trackers, and also documentation tools such as wikis. And most importantly, they also help you integrate and develop. And that is why I want to emphasize that using these platforms is very useful, and many of you are already using them. So that's, I guess I'm a bit preaching to the choir here. We are going to talk about GitHub mostly, but as I mentioned, you can copy or apply the workflow to other platforms as well. At FAU, you have the 3 different GitLabs available, unless your group hosts their own. There's the GitLab offered by the computer science department, which allows collaboration for anyone. So you can, if you have a project you want to collaborate with people outside of FAU, you can request an account for them and give them access to it. If you use the GitOS by RZE, which is the open source version of the GitLab, you can collaborate with DFN users. So any university that is linked to the DFN, so pretty much any German research institution and university, will be able to get access to it. And then there's the GitLab, which also has the enterprise features offered by GitLab, and that is only open to FAU users. And you specifically need to request an account. So if you are looking for these features, you need to request an account first before you can start using it. Now, we are going to use GitHub, which means that the platform is owned by Microsoft, and it is a paid service, but public repositories have all paid features for free. So public repositories have all the features that GitHub offers, and private repositories have a limited set of features unless you pay them money. And most open source projects you will find on GitHub. So that's why we opted to present the usage of that platform. But you can convert most of it to GitLab as well. So again, how to choose a platform at FAU. Is it open source? Usually go for GitHub. If it's not, then you have these other platforms available. Slides will be available later, so you can go back here. Then another intermediate thing, when you download codes from other platforms, when you clone, you will always want to use SSH. So you would typically want to set up an SSH key pair. Again, a reference to a previous talk where this was covered. Just as a quick reminder, this is how you set up your SSH key. And then you go to GitHub, you can add your key to your account using your profile settings. And then on the platform, you would typically use just a regular login or even set up two-factor authentication. Once you have all of that, we can start get going. So you would want to set up a new project, you can choose the owner. If you have an organization like we do, you can change the owner from your personal account to the organization account. You can get your repository name and some description, which is very helpful if you want to make your project publicly available as selected by default. And then there are also some other things that you can initialize your project or your repository with. We'll get into these later because they're very useful, especially if you expect other users. I would highly recommend setting these up. Now, once you set up your repository, you're going to have something just empty. And now you want to link it with what you have locally. And you have 3 different approaches that you can go from here. So first, you either have no local files, so you're starting from scratch. That would mean that you just clone your remote repository. So here we say git clone, always the git user. So we use SSH connection. That will only work if you have the SSH key set up. Then your username and the repository name, or the organization name and the repository name. And now you have a local copy, which has a reference back to GitHub. So when you do git push, it's going to push back to GitHub. Now, you might already have some local files, but not a Git repository. So there the approach would be that you would create the local Git repository. So you go into the folder that you want to start the repository on and already have your code in. You do the git init, place it everything into the main branch. Then you do git add your files, commit, and then you have your local repository and head on to the next part, which is the same as if you had a local repository to start with. Now you add the remote feature. So now we add the remote origin, that's just a name, as to point to GitHub. And then we set the upstream of our main branch to point to this origin. And then we push it and we can upload this to GitHub. Now, this may seem complex. We're going to show this first section and how to create a project on GitHub and this first part just in a second. But let's cover the initialization of a repository as well that I mentioned before, because there are a couple useful files that you should always have in your repository. So first of all, you should always add a README. The MD just says it's a markdown file, so you can get some nice nice highlighting on your some nice markup on your README, so links and so on. And it should tell people how to use your project, how to interact with it, how to install it, things like that, and pretty much how to get started. Then there should be a license file, which will GitHub will also automatically parse. So if you chose a license, it will highlight that on your project and mark it as an open source project. And a git ignore is very helpful, so you don't accidentally commit files which you don't want to have in your Git repository. And once you've created all of these files, never forget to add, commit, and push afterwards. So now I hand over to Thomas, who's going to show what we just talked about in practice.
Hello, everybody. I'm sharing my screen now. So you should see now on the right side a browser opened with a repository already created. So in our organization, on the left side, a shell. So what I first show is like how to get a repository. So if you go down here to the code, to the green bubble with code, you can select which methods you want to choose to clone. So I'm using the SSH method. So I'm copying that. And then I'm going here, git clone, copy that, and it's cloning it into the same name as the repository. So here now I have a machine state folder exact with the same stuff here in the repository. If you select a new one, so create a new repository, we have seen this page already. Here is the organization chooser. So if it's my personal project, it's under my personal account, or it's an organizational project, I add it to the organization. So let's do a demo repo. Interesting is here you can add these things directly. So a README file is basically added with some simple content, nothing spectacular. If you choose the git ignore and license file, you get drop-down menus where you get, for example, here some filter files. So if you want to have a Python project, for example, you can choose this Python template, which adds already like compiled Python files are excluded and so on when you try to add and commit stuff. Same for the license. There's already a license chooser. So let's take simply GNU v3, and then we create it. And now we have already these files. Cloning is exactly the same as before. And then here, if we look at the README file, so that's the markdown already. This is the raw content. So pretty simple. Whatever we write here, so we can directly change in the browser, view the changes here with some reflecting what is new, and then we commit it. Normally, you should write a message, of course, and afterwards it's written here. Yeah, so that is the first part. Let's see. Now we should be back to the slides. Yeah.
Okay, so so far we didn't really have any advantage over just having a Git repository locally. The only advantage that we have is we have a website, and may be nice, and that may be what we are looking for, but the big advantage comes from collaborations. So working together, or as Linus Torvalds puts it, I'm a lazy person, which is why I like open source, for other people to do work for me. And I must say, I wish. Of course, it doesn't work like that. But nonetheless, I would be interested in how many people are developing on your projects. So are you developing alone, or are you collaborating with more people? And of course, as you work in several projects, maybe things may be different from project to project. So for example, for me, I'm mostly doing things alone, but sometimes I'm collaborating. So I just put myself in the two-person category here. Okay, so how does that collaboration work in GitHub? So here we have different ways of interacting with a repository and the people behind it. So what we see here on the top, we have the code repository. And then on the left-hand side, we have on the bottom, we have anyone. So any person that has a GitHub account can do the things that are listed on the bottom on any public repository. I just let that sink in. Anyone can do all the things that are listed on the bottom to any public repository. So if you create a repository, if it's public, all these things will be available to anyone. And then the upper half, that is what is only allowed to people that have write permissions to that repository. So typically it will be the owner or other collaborators, or if you set up an organization, all the people from the organization, for example. And we have that bar in between where we have these three green parts, and these are the methods of interacting. So if some anonymous person comes by and uses your project or sees your project, spots a problem with the code or has a question, they will typically open up an issue. And they open the issue, ask a question in there, and then it's up to you or anybody else to comment or for you to close it. So that is some way of interacting. Then there is the way that you can edit the wiki. So the wiki can also be edited by all people, and you can add onto documentation and so on. That is also available to anyone. And when it gets to code, the code repository can be downloaded by anyone as it's public. As we just saw, the clone, that is possible. But if you want to go give feedback, and here it becomes interesting, where you can go through a pull request. So you create a fork, and then you can make some changes, and then you ask the owner of a repository to accept your changes. And that is what this pull request is all about. So you have the anonymous public that is allowed to give information to the owners and collaborators, which then they can filter and put into the code repository. And this process is even useful if you're collaborating with people which are not just anyone, which would also have write permissions. So if you go through this process, then you make things much more transparent and reliable in your development process. So are there any questions about this listing of features and what people can do here? Okay, if not, then let's quickly dive into organizations and collaborators, what these means. So organizations are a group like the HPC group at the computing center. We have shared ownership of the different repositories which are under this group. And then we can set up default permissions and teams, and also a public face. So we could have a public website for our organization, which we don't really use, but others do. And this is very useful for research groups and institutions, because if a person leaves, then the organization will still have ownership of the repository, and you can just set these up under this link. And then collaborators are individual permissions which you can give on specific repositories. Now, the ticketing system is usually the first contact between a developer and so an owner of a repository and their users. It's used for many different things. It typically you get support questions in there, but people also report bugs and features and have general discussions on this. So out of all the people that already have public open source projects on GitHub, I didn't really put a question here, but move to the left if you already had random people ask you questions about your project because you have it on GitHub and report bugs and so on. And move to the right if you don't. So if you haven't had any interactions by people that you didn't know used your project before. Okay, that's a few people have had that. Yeah, I've had it, and sometimes I even met people afterwards at a conference. So that was actually quite interesting. And then just some remarks on what you can use in the ticketing system is there are a lot of features built into it. So it's not just a ticket which is not related to your code at all, because you can reference to commit hashes by just putting the commit hash in there. You can reference other issues or pull requests, they're always assigned unique numbers. So if you put a hash sign and then the number in there, it's going to reference them and also place a reference in the issue and pull request that you reference to. So there's always a two-way connection here. You can mention usernames, which gives them some indication, and they can find these things easier. And you can also use checklists. So if you have a to-do list of things that needs to be changed to resolve an issue, then you would create these checklists and can easily check them once you're done. And of course, we can reference tags and releases and use Markdown and templates in here. So here we change to the demo again. Thomas?
I'm on the way. I have to say every time that I want to share my screen. So you should see that again. Yep. So here I have, again, the machine state repo. That's a demo repo. And here we can open issues. So here I'm opening a new issue. And I can say here, whatever does not work with Python 2. And then I can, for example, reference myself. In whatever commit. Yeah, so I can just copy it here. So these are the commits. If I just copy a link, like here, I copy that, and here, that it does not work for Python 2. Is that true? Well, I'm bad at typing today. So here, if we go in preview, we see already this one is highlighted and like has a mouse hovering thing. So you see already the long link was abbreviated to the commit hash ID. So this is how you can do that. You can here specify labels like this is a bug, or I want to have a new feature, something like that. So I can place here bug. I can assign somebody, or I can, if I have some project management thing where I defined milestones, I can put this issue to a milestone and say, this issue must be solved before we reach the milestone, for example. Yeah, exactly. So this is how issues work. So if we submit that, we see that here in the issue list, with this bug thing, and yeah, so that's how you can manage issues. So let me see whether I can go back. Yeah. So what I haven't shown now is the checklist. I will come to that in a minute when I issue a pull request. So that's the workflow to issuing a pull request. Julian, do you want to take over, or is it me again?
I can do it.
Okay.
No problem. Okay, so here, the blue line at the top, this represents our project over time. So we have our main branch that proceeds, and we get commits in here. Now, at one point in time, we are going to fork or branch this. So fork, if you remember the graph, what we had before, so fork is a copy of the repository by a non-owner. So you don't need to be owner of a repository to be able to fork it. So you create a complete copy of everything that is in that repository. And on GitHub, on the top right, you will always find this fork button. Branch, on the other hand, if you already have write permissions on that specific repository, then you can create a branch, and you would also be able to push that branch back to the original repository, which if you don't have write permissions, of course, you cannot. That's why we have these two ways, but nonetheless, they lead to the same workflow. And the workflow, the goal is that we merge back into our main part of the repository. So that step can only be done by people that have the right permissions. Now, to get there, of course, we want to make some changes, and we will eventually place a open pull request on the changes and our fork or branch, whichever we did, to specify that we want these changes to go back into the main branch. And this is where Thomas takes over again.
Yes. So should see everything now again. So here we go again in the machine state repository, and now I fork it to my private account. This takes a few minutes, no, seconds, normally quite fast. So here now it's in my local account, same name, and GitHub writes down that it is forked from this repository. So let's check that out. Git clone. Now do something like that. So if I specify a folder name afterwards, it's using this one. So now this is the repository I have forked right now. So what you normally do, or what is recommended to do, is to create a branch, even if you have the stuff locally, with some feature like new test, whatever. So this means that you switch the branch now. Then you do some changes, whatever. You take a new file and copy some code in there that I prepared, which is a totally useless test. Then we put that in the all tests again, also so that it is handled by the test suite. So if we run tests later, and then we commit this. You can specify it like that, so a star, so that it uses every file. But I recommend to write the whole files, because otherwise you might accidentally commit something that shouldn't be in the commit, and then you have to roll back the commit and so on, which is not that handy. It didn't know the file, so pretty interesting for you. So if you have created a new file that is not known to Git before, you have to add it, of course. Test new. So and now you can commit it. And now we push it back. Like that. So, and then GitHub already tells us that we can create a pull request for that. So I'm going over to the web page, and there you see already that GitHub notifies that I have pushed in a new branch, and I can compare it and create a pull request. So here is the base repository. So that's the main repository in the organization, which with the branch that I want. And here is my repository. It tells you already if there are some conflicts or not. And then you can, for example, here add something like test for empty is required, better documentation, whatever. Oh God. My keyboard is slightly broken. So in here you see these to-do lists. So this is also possible. And then if you create the pull request, it will create the pull request in the RSE repository. And now everybody could comment on it here. Look, new test. So you can discuss it or do whatever you want. So you can also add a reviewer here. So I can add Julian here, for example, as a reviewer. So he gets notified that I want him to review the code. So you get here pending reviewer. So for collaborating, it's always helpful to use all these features, like getting your code reviewed before it is committed to the merged to the main branch, and do some testing on it. Yeah. Now we should, yeah.
Okay. So what typically happens after you open the pull request, especially with a repository that is not your own, there's going to be a discussion. People tell you what they like or don't like about your changes, and you're going to add extra changes and discuss it with them before it eventually gets merged. So I'm about to show a little bit of that. So, okay. So here I see this new pull request. I can even see that there are two things in a list, in a checklist, which are not yet checked. And I can even go further into it and now start a review, which was requested here. So I can see the file changes, and I see when I can add comments on these lines or even a block of lines. So let's say missing doc string, and let's start a review with this. And now this is pending because this needs to be changed, and I can make a final decision. For example, I can approve it or request changes, and when it gives feedback to the original person that opened the pull request. So this is extremely helpful because now you see it in the comments. You see the code section that are highlighted. My comment, they can reply. I can say I resolved this conversation, and that actually opens up the doors for collaboration, especially with projects that you're not already involved in. Now, when we go further, actually, I wanted to show that in the browser. Now that we go further, that down here we see that we could, well, since I have write permissions, I could merge this pull request. People that don't have write permissions cannot do that, but they still see the things above here. So there are some checks which have been run. So this gets us to continuous integration, which is the next topic that we are going to cover. And these are tests which are run by GitHub and servers in the cloud for every pull request. So we can dive in here and see what is going on here. So currently these tests are still running. Down here there's a test which already completed. So here it ran all these different tests on the repository and the changed code, and all of them were fine because, oh, actually, oh no, these are just some debug messages, and eventually it gave us positive feedback that these tests checked out fine and everything else was fine as well. And we would need to wait a little until we get the complete picture that all tests ran. But that brings us back to the slides, because now what helps in this process is that you always have continuous integration in here if you set it up. So for each commit that you make, these tests are run automatically, and you get some feedback. For example, if tests failed, you'll get a red cross, and otherwise you may get a green check mark. And you get these for all these commits. And something else, that once you opened up a pull request, you will get them actually twice, because the pull request means that this branch is supposed to be merged back into the main branch again. So it simulates merging and then runs the tests on these as well. And maybe the result may be different because things may have changed in the main branch. Maybe additional tests were added in between while I was still working on this pull request. And so these things failed. And once everything checks out, then people would typically start merging. Now, this gets us to continuous integration. And what we would typically test for continuously is checking that the code that we produced and changed still builds. So does it compile, would be the question you would ask. Then you run unit tests. So does it still produce correct results? Then maybe a coverage test. So are more tests needed to cover the code that we added to our repository? Linting means that we check for the how the code is written. So are functions too long? Are the function names according to the standard that we said we would like to follow? Are variable names sufficiently well written, and so on? And then there may be things like matrix builds. So that's why you saw so many build tests in the previous example, because here we check for compatibility with different versions of operating systems and Python. And that produces a lot of builds. And then there's also something which builds on top of it. It's called continuous deployment. And here we would upload our releases and maybe even deploy to production. So in case of our Python project that we showed here, we would upload it to the Python package inventory, and other people could download and install it from there. All of this is usually done on every push. And you may ask, why would you do that? Well, first of all, it's kind of free. So there's not a lot of effort to setting it up. Once you have set up all these tests, then it comes free if you do it on every push or only once a month. It makes no difference. But it allows you to find bugs earlier, because every time you change something, you test for a lot of things. It encourages test-driven development, which means that before you write code, you write a test for whatever code you want to write. And specifically, when you find a bug in your code, I can highly recommend that you write a test for that specific bug and then continue on fixing the bug, because the next time you change something on that code, you may introduce that bug again, especially on complex codes. And doing that has saved me a lot of time finding newly introduced bugs. And it also, well, I have hated myself for not doing it before. So I would really emphasize on looking into this type of development. Then regressions, well, that is that you reintroduce an already fixed bug. So these two things kind of correspond to one another. And last but not least, it helps contributors to get engaged. Because if you have somebody that is finding a bug in your code, sometimes they wouldn't mind fixing it themselves, but they're afraid of doing something wrong. And if they have tests available and they're even run for them on the platform, they don't need to set up anything. They just make their changes and try it out. It really helps them get started on collaborating on your project. So that is extremely helpful to others as well. And it also gives you a standardized environment. So if you know things work on a GitHub action interface, then you will also be able to kind of compare it to your local system and find problems and differences there. So you may ask, why should I bother with tests at all? And there's a nice XKCD graph which tells you on how much time you can put into a task if you do it regularly and save some time. And it's surprising, if you do software testing, how much time you can actually put into software testing, because bugs you will be searching for a lot and very often in your code. And anybody who tells me otherwise probably doesn't develop software. And if you do that more often, then it helps a lot if you have a test framework which does a lot of that work for you. So some, well, guidelines. If you have more than one developer, you should really write tests. If your code is complex, then write even more tests. If you plan on developing long-term, that's where this graph here on the left comes in, because you're going to do that task for a long time. Then you write even more tests. And if you want to enjoy your life and not do the tests manually and have test protocol, which maybe is written on a paper somewhere and you do it every time a little bit different, then you should really write tests. And that being said, it's always worth the effort doing that. And it's so much easier once you have something like GitHub Actions or any continuous integration service that you can rely on to run the tests for you. Now, again, a question, now that I've said so much about it. So, do you have software testing? Well, I hope I made my point. I would highly recommend going for tests at all, and then going for the automatic tests as well, because it will save you a lot of trouble and makes your life easier and opens up your possibilities for collaboration much easier as well. Now, continuous integration with actions. So GitHub Actions, that's their service called. You've already seen the outcome. And now I'm going to show you how it's configured, just briefly, because getting into it could be a whole talk on its own. So let's see. Well, some of these tests, okay, these are still running in the actual tests. Some are already finished. But what is going on behind the scene? So we go into the repository, and here you see a special folder which is called .github/workflows. So any YML file that is in this workflows directory is going to be used for testing. And here we define how our tests are going to be run. So we have a name, we say when it's going to be executed. So in our case, on all pushes and pull requests. And when we define a job, can be multiple jobs as well. And in our case, we run tests and we also publish. We have matrix builds, so we run it on different versions of Ubuntu and Mac OS, and on different Python versions, and they all get combined in any combination. When we define how our software needs to be installed, there may be some pre-requirements that I set our environment up, and then we actually install. Okay, so up here we do the installation of our dependencies, and down here we install the actual package that we have. We run the tests, and we also check for the coverage, which is another service that we are using. And then finally we build the package, and if it's a push to the main branch and also a tag was set, so a version tag, we're going to get into that later, then it's going to be uploaded to the Python package inventory, so the package repository where anybody can install the package from. Now the coverage will end up here. That's a web service where I can look at different commits and see which part of the code our test cases covered. So when I go through the code, so I had 20 test cases which covered this section, and 15 test cases which covered that specific line, but I had no test cases which covered these error portions or this part. So maybe I want to improve my tests to go through other parts of the code as well. So that's just an additional info that I can get into.
Thanks here. That I should write more tests.
Yes, very subtle, right? But you could also have other services linked to it. So, for example, you check for the coding style if you follow like a recommended coding style and get some feedback on it. And it's even possible that there's like an automatic review if you make a commit in a pull request. It automatically comments on all the portions that your code didn't adhere to a recommended coding style, for example. Okay. Now to tags and releases. So versioning your software is important once you start releasing it and making it available to other people. And again, here we have our repository and we make some commits, and eventually you say, okay, here, this is going to be one release of a specific version. And that's what you can use tags for. So I use git tag and then just some name, which typically would usually be v and some version number. And then we can push the tags to our origin, so to GitHub, and it'll be available there. Thomas is going to show that in a bit. Now this marks a defined state. So this name is always referencing to that specific commit. And if you remember the commit hashes, they're just a long list of random numbers and letters. So that is not very useful to remember. So that's why we have these tags here. It's also easy to go back to that specific version because we can just do git checkout the tag name and it will get us there. And it's also basis for releases. So GitHub, it's not a feature of Git, but GitHub has the notion of releases where you add, okay, we have another tag here, where you add extra information. So for example, some compiled files or generated files that your code requires for publication. And you save that alongside with the tag on the platform, and then other people can download this build package, for example. So this is where Thomas takes over again.
Yep. So I'm sharing my screen, and we are doing now a real merge. So this is a pull request Julian and me have worked on the last weeks or so. Here you see again this coverage report. So we lose a little bit of coverage with this pull request, but that's not a big deal. It will come back in the next pull request. So we can merge that here, and then it is already in our main repository. So let's pull the fresh data. So here we are. And so I could add a tag on that. So now, so like something like that. No, I'm in the wrong. branch. So pull again. So now everything is there. So we tag it, we push it, and this means that here on the web page, you see here on the releases side that we have a new tag. So this is here, and then we can draft a new release. We'll say here for 0.4. That's the tag I want to use, and this is called machine state 0.4 edit from dict functionality, and then you publish the release, and then it is shown in the release page. So where it's already packed the zip and the tarball for you, and marks the latest releases and so on. And here on the right side, you see that now this is a release, and where now these GitHub action is running at the moment. In the end of the tests, it will push this release to this Python index, and so it's available for everybody like in 30 minutes or something like that. Yeah, so tags are the way to specify specific versions in your code, and mark them as releases in the on GitHub, so that everybody can download it. So let's see. So here we are back. The last feature we want to show is the stashing of changes. So stashing is something like a temporary space for your data. So if you're working together, it's often that you manipulate the same file, like a central make file or a config file, or even work on the same portion of code. And then if you need to revert back to the head without losing your data, you have the possibility to push your changes on a local temporary space. So it looks like that. So if you do a git stash push, it's putting it in the stash, and the repository looks like before without any changes of view. If you pop it again, you go back to the previous state. So you can switch back and forth. So here, if we look at a repository, I'm just doing a example of that. So we are changing to this branch. So we think we are working on this branch, but then I want to add something to the machine state, to this getHTML function. So here we write everything in bold, for example, and I want to remove that. So let's do it. Releasing the bold tags, and then I see, oh, I'm in the wrong branch. I have to change the branch, and if you do a git checkout in the other branch, it tells you that you have already changes in the files which would be overwritten by the checkout. So this is like
I don't see the screen share.
Really? Oh. That is, it lost it somehow. New feature from Big Blue Button. So do you see it now again? Yeah? Is it visible?
Yes.
Okay. Okay. So we have been at that point. So you haven't seen probably the pushing of the tag as or was it still visible?
That was still visible.
Okay, so here we let's go back. So we are currently in a branch here from dict. That's the branch I currently I merged a few seconds ago, and I want to work on it. So I'm doing something here. So here in this case, I have removed the bold tags. I can do it in the second line as well. So here, we remove the bold tags from the HTML output. And I think, oh, it's the wrong branch. I have to go to this valid HTML branch. So I'm doing a valid HTML to go to the other branch. And there you see that you have local changes in this file, which would be overwritten. So now you have two possibilities: either throw it away, commit it in the current branch, which is not what we want, or we can push this file on the stash. So it is saving it. Now we can check out valid HTML and pop it again. And here we see already that it's trying to auto-merge it. In my case, it has a conflict. So if I go into the machine state file, I will find these, where is it? Here. So here we have that's the original one, and that is the stash changes. So we can remove the one that we don't want to, so like that. And commit it. And then we are done. So we can use it to temporarily move changes to a stash space before we can manipulate the repository again and do something with the repository. Yeah, so that's the background. Wait, so now we are back again. So stashing might be, there are many use cases for stashing. It's like a hammer. You can use it for many things. This is one of the use cases I have sometimes. And I use Git Stash like for the last week since I prepared for this talk. I haven't used it before. So it's a new feature for me, but it's quite handy at some point. So then we just noted down some additional features that are available on GitHub and as well on GitLab and all the other collaboration platforms. So forking, I've shown that and we have talked about that. For collaboration on a project, fork it to your local account and work on that, probably with branches in your fork repository. And then you create the pull request across forks. So there's a selection at GitHub where you can compare across the forks. And then Julian has mentioned it shortly for documentation purposes. There's the wiki. The wiki, there you can show use cases, a project website, some help, and so on. I could show the wiki of Liquid, which is quite big. So it's the main point of documentation for the Liquid project from us. If you are in the free plan, so you don't pay for GitHub, you can use GitHub Pages for public repositories. If you pay, you also can do it for public ones. And GitHub Pages is basically a web page hosted by GitHub for you. So you can exactly tell what it should show there, pictures like a web space at the university or somewhere else. And the last feature, which is quite handy and quite new, is getting a DOI by Zenodo. So you can cite specific code versions, for example. We have that in a paper lately. We reference a specific version of a software so that everybody knows, okay, if we want to reproduce the research, we have to use this version of the software. Zenodo is financed by the EU, so has good money behind it. It's a cloud storage for papers, reports, videos, software, data. So the main purpose was data, to share research data. But in the meantime, they also added like papers and reports and software, especially. It integrates nicely with GitHub. GitHub Lab is in the making, so they are working on that. But every time you create a release on GitHub, it might push it directly to Zenodo, and you get a DOI for the new release. So this is automatically handled for you. The setup is quite easy, and you just need a Zenodo file, JSON file in your repository. I mean, I could show that if somebody's interested in that. Yeah, so pretty handy feature and nicely integrated. As this is the final slide of our talk, it just gives you links to documentation of GitLab, of GitHub, about Git in general, and also special links for continuous integration with GitHub and GitLab, and again a link to this Git game, which is really nice. I played it and I learned a lot, and I'm using Git like for the last whatever 8-9 years, so it's still something to learn from.